Oh, hello everybody. How's it going, Slip? So, um, today I want to start a series of sorts. I'm going to make an RTS, alright? So, and I sort of thought about this, what kind of game I want to make. I've been wanting to make a full game for a while, but never quite got around to it. So, I'm going to write a game from scratch, or mostly from scratch, and then just document the process. So the kind of game I want to make is sort of like Seven Kingdoms. And if you don't know that game, I'm just gonna show it to you. Okay. So this is that, and yeah, this is quite a very simple game. Here I have previous games. Let's see. So you see, it's quite a simple game, right? So you have some villages, and from the villages you can train villagers, in different things, right? So you have constructions, or soldiers, or miners, whatever, etc., etc. And you can build forts and put your soldiers there, and you can build weapons, and it's an RTS, right? You have to establish trade routes and things like that. So it's mechanically it's not that difficult, but yeah, it's just nice. I think it's a nice kind of game, and it's not it wouldn't be too much of a hassle to get something kind of like that done. So first off, what I'm gonna do is I'm actually going to make it part of my ongoing system thing, right? So um, first off, what I want to check is if, okay, because I want to make a repository out of this, but I don't quite remember how this thing worked. So let me just check it real quick. Okay, it's just new repo name. Okay, all right, that's fine. All right, so the name I'm gonna give it is Throne. So it's Throne, right? The original name I had is Throne of the Unforgiven, but that's Throne of the Unforgiven, but that's too long, so we're not gonna do that. We're not gonna do that. So yeah, just checking that this is recording. It is. So okay, let's just do right here. Let's just do new repo Throne, and it's gonna be capitalized just for reasons. Okay, and so now I want to clone this. So that should be yes. Um, do I need github.com Libranca from okay. Try getting that, and there it is. Okay, let's walk in there. We have our license, and let me just check that it is the right license. Yes, it is. So this is going to be entirely GPL, part of the reason why I want to make it all from scratch, right? So yeah, I'm just going to make this here, and I'm just going to move the license into docs because that's something nice to do. So let me just check that it is. Okay, all right. So first things first, let's make a readme for this, okay? So let's say docs readme. Let's go just plain readme. Okay. So we're gonna say Tron. This is a work in progress. This is a whip RTS written mostly from scratch. All right. So let's say goals. All right. Let's just set a few goals for the project here. All right. So the first thing I want to do, we want to have little micro management, right? Because I don't like, having to tell the villagers where to go. So I just want to say, put more villagers onto gold or something, right? And that would just happen without me having to do much. So it's gonna be the kind of game you can just leave in the background and not, babysit it all the time. So this is the most important thing that I want for this kind of game. So there has to be some strategy, but it shouldn't be too much, right? So for graphics, we're gonna do entirely ASCII for now, okay? So ASCII graphics for now. And what else? Well, we want heroes, right? So little micromanagement, and we want the unit control to be centered around heroes, right? So you have like leaders kind of units, and they sort of direct the rest of the normies and tell them what to do, something like that, right? So yeah, let's say unit control through. I'm not gonna say well, I'm just gonna say heroes because it's people will understand what it means, right? It's just one of those things. It's like shooting a arrow, right? You know that it explodes. It's just common sense at this point. So anyhow, the view is going to be top down. So now, so let's say top down view, and yeah, and ASCII graphics, it just let us know that it's 2D. But I'm just going to. Okay. Yeah, and this one is actually top down view. All right. So yeah, I'm going to do the graphics. Actually, the graphics is like the first thing, actually, because I need to be able to draw, right? So, but it's not going to be overly complicated, actually. All right. So, I'm going to write some of the, let's say, the front end. I'm going to write it in Perl, all right, because I'm crazy and I like Perl. It's a nice language. So I'm going to I don't know if I should actually write this part, but so but yeah, I'm going to do the front end kind of work in the scripting. I'm going to do it in Perl, and the back end, I guess, C or C++. And I already have ways to call C code from Perl, so basically I got my work cut out for me. All right. So the first thing we should do is the drawing stuff, right? And this is usually kind of weird to think about, but I'm gonna try. All right. So yeah, let's just get right down to it. I'm gonna um, uh, what was it? Make X, is it? It must be in my config. I'm sorry, I'm a little bit slow. That's all. Because I know I have a command to do. Yeah, make X. All right. Yeah, just create the file and make it an executable. So it's a shorthand. To make X, and I'm just gonna call it game. All right. Make X game, and now nano game, and I'm gonna just going to be a standard Perl script. Right. So, Just gonna do the docu real quick. Cron small RTS. So yeah, cron, and we're gonna say libre software license under GNU GPL3. Whoop. Behavioral and inherit contributors live. That's me. Okay, all right. And I don't need to do this because this is not a module, but it's just one of those things I like to do. So, what am I going to be using here? I want to use, well, first the good pragmas. Actually, let me reload this. So now I have my syntax highlighting because of this thing, it recognizes it as a Perl script. So I want to use the good pragmas, obviously. And also I want to use my library because that's why I write them for use them. Yeah, live. And I'm gonna use cache. That's the name of a library I wrote, where I have a lot of funky string manipulation stuff. So because if I don't use this library that I've already written, it will be writing the code from scratch all over again. I don't want to do that. So yeah, I'm just gonna use cache. All right. So the first thing in order is we need to have some concepts down, okay? And this is actually not that tough. I already given it some thinking, and it's not that difficult actually. So I'm just gonna say package main just because. And what I want to do is I want to have let's say four kind of objects, let's say 4 classes. Right, so we're going to have scene, and scene is simply going to be a collection of entity with some added thing. So entity would be either a building or unit. Scene would comprise the terrain, the actual map, plus the entities within it, or note of where the entities go. Scene is also going to contain how do you say the view frustum, right? So the part of the map that we're actually interested in. So it's going to do multitasking, so to speak. It quite far from a God object, but it's going to do some multitasking for us. And besides that, we need the grid itself. So scene is going to have a grid, and grid is basically just a bunch of squares, right? And each square will give us some information about what's in it, and we're going to use that for the path finding and things like that. I could make grid a part of scene, but that would be kind of weird. And then we'll simply have a canvas, and the way this is going to work is canvas is going to just have a generic dummy function called draw, and what draw is going to do is it's simply going to look into the frustum within grid and scene, look at the different entities and information of what should actually be on screen at that particular time, and and draw that according to whatever we replace draw with, right? So it's going to be a void function, right? A nihil, right? So nihil, that's I love explaining this, man, but it's this, right? So it's a function returning nothing and taking nothing, okay? So it should read from global state. and that's actually kind of easier to manage. So okay, these are the 4 classes we need to write. Okay. So all right. I guess I want to begin with the canvas, actually, with the canvas and the grid, right? Because scene I should give some second thought, and entity. Well, I mean, actually, I could sketch them out, I guess. Just let me have a drink here. So, I mean, I sort of have some idea of what kind of attributes I would give to entity. About scene, I'm not entirely sure yet. So I guess I could sketch entity out. All right. I'm sorry I take so long, but you know, I like to sit back, do some thinking about what I'm gonna do. Okay, so I want to take a look at cache. That's in the help module. Because I don't. Oh, all right. So because I don't quite remember some of the functions that I have here, and I could as well, you know, do some cleanup because some things might not be so tidy here. But I remember I had some functions here to sort of help me with writing ANSI escapes and things like that. And if I'm going to do drawing entirely with ASCII art, it's going to be kind of better. Oh. I guess the first thing I should do is try and draw a board, right? So we're gonna keep this in the back of our minds. I like leaving notes for myself and things like that, but yeah. So for now, we're just going to do a generic draw subroutine to try and get a, how do you say, to try and get a grid, a board going, right? Like a chessboard. So let's do, oops, I'm sorry. So let's do something simple. Let's just draw a bunch of squares across the screen, and for that I need to know the size of the screen, and I can get it with this. So that's cache tty size, right? Let me actually see how I'm getting that. You never know. I might be doing it kind of weird. So I was doing this with the right. So this is actually the right way to do it, but I don't know. I guess I mean this is alright too, but let me check something here real quick. Help. I have this thing here, and I know here I'm getting the. So this is for another application I was writing, and I sort of forgot about it, but let me just look real quick how I was getting the screen size here. I think I'm doing it through a C. So right the. Oops. So what I commented out here, I'm pretty sure I have this on a C library, and I'm calling it from here, but I don't quite remember, so let me just check real quick. Must be on the drawer, right? TTY size, and yeah, like on TTY size, yeah, exactly. So, and I can just import it like that. So actually, let's do that. So Lycon, it's a Perl module that has a binding using FFI platypus. The last series I made here on YouTube was basically some of the work that went into automating the generation of those bindings. So Lycon is automatically generated bindings to C function. So I'm just going to use the Lycon TTY size, and let me check how I actually call that. Okay, so I just have to send it a reference to an array. That's easy. And my y size equals to ints, and here we want to send that to C. Okay, and so that array will be filled out by this function call, I would hope. Okay. So all right. All right. So I want to do a screen wide drawing just to check that this actually works. Actually, let me move this around a bit. Okay. All right. And I'm actually just going to call this function. And let me think for a second here. I I really do hope that this is compiled, because if I didn't compile it, it's going to complain. And I don't want to be fixing the automat module right now. But if I have to, then I have to. So anyhow, let's just take just draw across the X, and then we'll think about it. Okay. So I guess I'm going to do it the C way, right? What could go wrong? So X less than TTY size is 0. I'm hoping that X is 0, because that's what I'm used to, but it's not. I guess we'll find out. Whoop. So let's just accumulate to a string. Oops, not plots. Dot. And let's just put an X there. Why not? Actually, a monosign. That's my favorite. Okay, so let's print that out. And yeah, and that's that. Okay, so let's run it. All right. So this error message here is because I'm using another like an experimental version of FFI Platypus, and I don't know how to disable this warning. Kind of rude that it would give me the warning every single time and not let me disable it, but that's fine, because we're gonna clear the screen, so you know what you're gonna do. So actually, let me check in live here. I'm gonna take a look at Lycon. So I might have a function to clear the screen, because it's a lot of functions I wrote for keyboard keyboard functionality, like enabling me to detect almost all the keys in my keyboard, and having program clocks and things like that. It's kind of fun. Click neat. So this is for the program clock, but I want to see if I have a clear screen. No, this is all for events. This is for switching the TTY. Yeah, I remember that. So this is a fun story because Alt and the arrow keys, like left and right, I would use that to switch between TTYs because I was not working in with an X server, so I was working in the virtual console, so no graphics. And whenever I would enable the raw keyboard mode, I could not switch, and that was annoying. So I wrote a function to do it, and basically rewound it to the same thing. But now there's no. For some reason, I do not have here a function to clear the screen, so I'm just gonna do it the old-fashioned way, and that's um. Well, I guess I'll just. If I remember correctly, that should be 2J, right? We'll see. All right. Yeah. Yeah, that's fine. So then I have to move it to the top. All right. Yeah. Okay. So there we go. All right. So I guess I want to do that at the beginning of each draw. Why not? Right. So it's kind of annoying because you get to see the warning, but not much I can do about it. I just have to deal with it. Yes, I'm going to initialize to this, and I'm not going to be drawing every frame because why? No, I'm only going to draw when I have to. But we'll look at that later on. So, okay. The way I'm gonna go is I'm just gonna treat every character in the screen as a cell, because why not? And I guess we'll make it so every entity can take up more than one, right? So like the basic units are going to be like one cell, and then like a building is going to be like a couple, like a couple squares, something like that. Maybe when if we have something like cavalry units or things like that, we can make them take up more space as well. Though I don't really like it when it's like that, because then the unit movement, it's all messed up and I don't like it. Okay. So we have the screen size, right? So for starters, what I would do is just draw a grid and try to get some logic down, and we'll use the draw just to see. So the first thing in order would be to sort of draw the grid, and then we'll try to how do you say, to fill out the grid depending on which entities we have in there. But first, what we're going to do is how do you say this? So, I mean, here's the fundamental problem for pathfinding, and I know I'm thinking ahead of time, but it's sort of what I have to do. if we have a bunch of cells here, I'm just going to do them sort of like this. A cell can basically be in one of two states. It can be free or it can be occupied, right? So it's going to be, it could be occupied by something that's not living, you know, something like a tree or a building. And in that case, there's not there's no way around it. You know, you have to evade it. But if there's a unit, you know, something that's living, you know, so a living entity and an entity that's friendly and an entity that's not busy, you can ask them to move, right? So suppose, you know, you have your unit here and you're trying to move and this one is in the way, you can ask it kindly to move, to step aside so you can move, right? But if this unit is friendly and if this unit is not busy, because asking it to move when it's busy, that would be rude, right? So yeah. And so the first thing in order would be to sort of have a way to know if a cell is occupied or not. So actually, what we should do is grid is going to be contained within scene and it's going to be a container of cell, right? Okay, so I guess we'll do cell first. That's fun. Okay. So, I should do it in its own space, so it's a little bit easier. Yeah, why not? So let's say, oops. Okay, so cell.pm. Okay. All right. So let's just do this real quick, and I don't have to do this the shebang here because this is a module. I'm not going to execute this file, but you know what the hell. I like having this up here just to know that it's a Perl script. So it's going to be cell, and the cell is going to be spot on a plane. You know, that's a good way to describe it. So deliver software license under GNU GPL3 BA grow and inherit contributors live. Okay, that's me. You can say live, live, same thing. So okay, so depths use strict use warnings. Okay, so the good pragmas. And because we're not going to be dealing with any drawing at this level, we'll just okay. Because we're not going to be doing any. I'm sorry, I keep interrupting myself, but because we're not going to be doing any drawing here, we do not need cache and we do not need Lycon, probably. Okay, so the first thing in order would be to do a init. So that's initialization, no? So this is a constructor. And I guess we're going to pass in coordinates first, right? So my x, y, I'm just going to do it like this. Why not? And my cell is going to be a bless, and this is how you, yeah, I know it's kind of weird, but this is how you make classes in Perl. It's kind of stupid, but you know, like, you know, whatever. So okay, I'm going to say, because this might we might have different coordinate systems, so actually I'm going to say world x and world y. Okay, y, and I suppose I need getters, so let's do those. And I like putting the getters up here. To world x, actually lowercase, so we know it's instance and not global, right? because if you put it like this, it looks more important, right? So that's good for a global state. So let's just do, actually I can do this in a single line. Shift world X, and here we get the world Y coordinates. Okay. All right, nice. So we can know where each thing is. So what else? So we need a way for each cell to be able to sort of know some things about its neighbors, because that's sort of useful when you're pathfinding, right? So you don't need to know what's around you. The cell should know what's around it, right? And so anytime you modify that state, you can modify it for the surrounding cells and just expand from there. So actually we do need to have a state for each cell. I'm just going to start it at occupied, and I'm going to have some constants for this to make it easier. So I'm going to say I'm going to say flags. Yeah, let's constant. Oops, constant. Right. So I'm going to say F for flag, and 3, and that's going to be 1. So let's do it like this. Or actually, I'm going to do it in hex just because. And F occu for occupied, right? Okay. And then we can have some additional data. So what is occupying, right? That would be kind of nice to have. State, we just want to default it to 3. Oops. And yeah, if you ever take any sort of course, right, for game developing and such, they will tell you that state machines are bad. Not really, but some people are superstitious. That's just how it is. And I mean, I'm I know, no, I'm not trying to be rude or anything, but I mean, I'm religious, and I consider people who say things like that to be superstitious. So go figure, right? You know, like like belief in God is less of a superstition than thinking that state machines are inherently bad. Just saying. But anyhow, um, should we have a reference to whatever is occupying? No, we should have an index, because a reference, it's probably going to be larger. Um, I want to deal with that just with numbers. So I'm gonna have occupier, or that's too long. Naming is usually the worst part here. Yeah, so I'm just gonna say Aku. And actually, look at that. So I don't really need a state here, because because is occupied now is now just actually, I'm not going to do this as a one-liner because I want to be a little bit more cool here. Okay, so is shift, and we want to return self self Oku is defined, right? And so Oku would be the index of the instant of the entity occupying this cell, right? So it might be a building, a tree, I don't know, some other resource or a unit, but it's something. It's on this cell, okay? And so state, we're gonna use it for something else. We can say, for instance, we can have like some cells be higher up, right? So on a hill, and so that units on a hill will do extra damage or some things like that, right? So it's fun to do that. Or maybe the cell can be on fire, or you know, things of that nature. So actually, let's do that. So let's say f none, and then we can have fire. Let's say water. How about acid? I'm just making things up here. If I don't add them later on, just whatever. No? But it's fun. I mean, it's game dev, right? It's fun to have things like this. Just let allow yourself to dream a little. So fire, water, acid. What else? Uh, Hill. Yeah, why not? And the cool thing about doing this with flags is, you can have them all simultaneously. So that's kind of cool. Okay. Yeah, I think that's enough. Okay. I'm just gonna default it to none. And actually, I'm not going to return state directly. I'm just gonna say, and oh yeah, I need to find this one as well. Sorry. Return, oops, shift occupier, right? Hmm. Hmm. Oh, so I right. So I can do that in a single line. I know it's kind of confusing, but just what it is. Okay. So what I want to do is do a sort of a thing like this here. And you know what? Actually, I'm just gonna have state because why not? It's kind of weird having to write it like this every time. So yeah, just gonna do it like that. Shift state, and then I'm gonna have is on fire. And I know this is uh not really important, like do this, but why not? I mean, why would you write an RTS if you cannot put things on fire? Let's say, yeah, is a flame, is poisoned, and basically what we're going to do is whenever a entity is on a cell, it's just going to inherit this state, and that's that. And so you can, uh, if a unit, if the on is a flame state lingers for when an entity exits the cell, well, we'll see about that when we get to it. But and the is on water. Is at sea. Okay. I could say, is wet. I think it's better. I think that's a better way to phrase it. All right. So anyhow, enough of that. Um, I want to, well, first I need the constructor to return the instance. Oops, return. And we do need to have some information about the surrounding cells. What I'm gonna do is I'm just going to do it with a bit mask, okay? So we're gonna have a surround, and it's going to be mask here. Actually, I'm just gonna call it surround, and the surround. Let me think about this for a second here. The surround should be a bit mask, right? And we're gonna have so this would be all the possible neighbors of a single cell. This is our center cell, right? So this is the new instance, okay? And so we can have 1, 2, 3, that's 9, no? That's, or, oh, is it, oh, it's 8, it's 8, okay. Right, so that fits in the chart. Beautiful, okay. So what we're going to hold in here is whether the surrounding cells are occupied, because that's going to make any work we need to do much easier for pathfinding and such. Because I mean that's the main point of having this. It's sort of to so that how to phrase this. It's what we want is to have some spatial awareness. Okay, so I suppose if we later want to get additional information about a neighboring cell, then we can just look it up. The way we'd look things up be and I know I said I'm gonna have the grid on the scene, but actually the grid is just going to be a part of the global state of cells, because why not? So global state, and I'm gonna say my cache. Oops, no, and actually that's like that. Okay. So grid would have to be a matrix, right? A two-dimensional array. So basically, you would go grid x. Actually, it would be x, y, and that gives you the cell. Okay. So that's just like that. And so let's add a. You see, it looks more important like this. Huh? The letters did something funny there. I don't know what it was. Okay. Anyhow. Let me just move the camera a little bit. Because I don't like my face being on screen but it not being properly centered. I think it's kind of stupid that something like that will happen. Okay, and anyhow, we're just going to return cache grid. Okay, that's fine. And what we're gonna do, and I'm gonna leave this drawing here just for illustration, so I can remember. I'm gonna say grid at x, y, or should I do it the other way around? Nah. Or is it gonna be because usually when you do this kind of thing, you do it like this, right? So you have, this would be 0, 0, right? And so you say, you know, row 0, row 2, row 2, and then you index to this. Yeah, so it makes more sense actually. Yeah. Let's save it there. And right, so here we have a problem. Actually, what I would need to do is create this beforehand, so that it already knows it's a list of lists, right? Or a array reference to a list of array references. A reference to an array of array references. So let's do another knit, okay? So sub make grid, and I'm going to have my x and my y, and all we're going to do is just iter, okay? So for my y less than size y and y plus plus, all right? And I think there is a more Perl way, a more a more Perl-like way to do this kind of iteration, but I'm a C programmer, so this is actually kind of the way I do things. I don't know. And I mean it's obvious, immediately obvious what this is doing. So yeah. So the first thing we have to do is on the first run to say that that grid at y is equal to a anonymous array reference, right? Because then we can say, you know, push to that block. Actually, what I'm gonna do, say row, so now I can go row, push, just push on there. Not good enough. Oh, actually no. Actually no. What I can do is just knit and pass x and y. There we go. Okay, so that would construct our grid system. Okay, and save all of our cells to the grid, and so we don't actually need to do it like this. Okay, so that's a wrap. Nice. Right, you see, I didn't even think about it. I just said, you know, it would make sense to initialize this. Well, that's actually quite convenient. It's actually quite convenient. So nice. Okay, so how long? Okay, so about an hour. That's okay. I don't want to make each chapter too long. So I guess we're going to conclude this one with just drawing the grid. But we'll see, we'll see. Okay. Let me just have a drink here. Okay. I guess that depending on what's on a grid, what's depending on what's on a cell, is what we're going to draw. We're not going to do multiple screens yet. I'll see about that later. For now, it's going to be just a single screen, right? So this static grid will be enough. We're not going to be having to overwrite anything as the camera moves, because there's no camera, just one fixed a TTY size map. That's good enough for starters. You know, I firmly believe that you sort of have to do the initial implementation of like the most minimal use case, and and write it in a way that's methodical enough that you can just go in and add more stuff later and not have to think too hard about it. That's usually the best approach. Unless you have a team and you can plan things ahead like really nice, but that's usually not what happens. Usually plans go to shit really quick. So yeah. Okay. So now let's put, thank you. Single cell organism, I should put, but static. I have to say knit. Right, so knit is a shortening of init, which is a shortening of initialization, is how you spell that? Knit. It's a knit. So okay. Alright, so what I'm gonna do, actually I can have two masks now that I think about it, because we're not gonna have a, how do you say, we're not gonna have a cell beyond x0, and we're not gonna have a cell to this side beyond x size x, right? So actually, let's just undef this. And I am gonna have to set this manually, but that's only going to happen once, so it's not that big of a deal. I'm gonna do that here. Now I can just size y, size x. Okay. It's just, it's just shortening things, so I don't have to write all of this every single time. Okay. What I should do is, first off, think about which cell is which. I suppose this one is 0, 1, 2, and then 4, 8. All right, I have to skip this one. 8, and then this one will be 16, 32, and 64. Wait a minute. No, this is 1. Okay, I skipped a bit. I skipped a bit right there. Okay, so 32, 64, 128. So this corresponds to each one of these bits. Okay. So what I would like to do is, well, maybe we can have multiple of these bit masks. just to know what. Or it can be, you know, an array of information or something. Okay, so let's actually define some constants for this. So I'm gonna say S for surround, and it's going to be up and left. So up and left, up and left. That would be 1. Up and mid, that's 2. Up and right, that's 4. Okay. So down, 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 and that is, we said, oh, I am stupid. Okay, sorry. I made a big mistake here. I made a big mistake here. Because I began writing this as a binary, and my mind just, I immediately noticed. Not quite, but kind of. Okay, so 16, so that's the middle, and the right, that's 16, and so this one would be 32, 64, and 128. Okay. The round, left, left, and oh no, right, right, right. So I could say middle right, side right. Why not? And side left. And side left is 8. Okay. Let's take this, put it in our flags. Now, one thing we need to be able to know is whether there is a cell at a given neighbor, right? So basically corner and edge cases, literal corner and edge cases. So the way that's going to work would be sub S for surround, UL, so up and left, that would have to be shift for this one. And how does this work? How does any of this work? How? Just how? So it's grid self world X, and yeah, I'm just going to use the world coordinates actually, because at some point it's going to be the grid is going to be bigger than just what's on the screen. So yeah, I would like to access it to the world coordinates, I guess. Or do I? Do I? We'll see about it. So up and left would have to be y minus 1 and x minus 1, and that would be my neighbor. And if not defined neighbor, all right, so I can just return this. say sub as full. Actually, I think I want to use n per neighbor. That's actually okay. So if this is not defined, it's basically the return defined shift and up left. All right. And now basically I need to repeat these for every neighbor. Yeah. Yeah, that makes sense. Which this is actually kind of dumb, but I'm just gonna do it. I guess I could be more funky about this, probably, but it's faster if I do it like this. Okay. This is just to check that a cell has a given neighbor, right? So if there's no more grid to a given way, you can tell you have a method, to know that. And I mean, it's easier in my mind to give a name to that operation and just use that operation whenever I need to. Then have to pass arguments to it, and then I would always have to remember what the right arguments are. Oh, right. So what I could do is to get neighbor I'm actually, because I'm fetching from the grid, I'm actually going to invert it here. And it's going to be the prototype for this, right? So it's going to be like this. So y plus y and x plus x. And so then I can just say get neighbor and the coordinates, right? And so you're basically, this is a prototype, and here you just have the actual application of that. So all we said was -1, -1. And yeah, that's fine. Okay, so now it's shorter. Okay, so it's still a lot of methods. right? And so this will return an instance, a cell instance, so it's kind of cool. And what we want to do is, have a method to get that neighboring cell, and a method to know if there even is a cell, because else you always have to be doing the is it defined. I don't like it. So anyhow, so now we do the middle. And the right. And this would be the side, and there is no mid inside for reasons. Okay. Just to be petty. This should be the down. Yeah. Right, and the rest is exactly the same. Oops. Like that. And has a side right and right. Right and right and right and wrong. And right and wrong and right and wrong. Okay. Okay. All right. So that's a lot of methods. We could just do this call every single time, but I wouldn't like that. So yeah, just to save me some time, right? Because because this name saves me all of this, and this name saves me all of this. It's a petty kind of aliasing thing. Um, Fetches. Okay. All right. So that's an hour and 12 minutes. All right. So let me think. What I want to do now is have a method to know if the neighboring cell, if a given neighboring cell is occupied, right? So let's say, for instance, we want to check if the cell to the side of us is occupied, right? So is side left occupied, right? Because this is how we would determine can a unit within a cell move to the left, okay? And so what we would do is, first and foremost, shift if self has n side left, whoops, if it has something to the left, and solve neighbor side left is OQ and is free. It's basically the same thing. Right? So this is not defined, right? Then we can move, right? So return 1. Actually return 0. Right? Okay. And so now we cannot move to a cell without knowing if it's there or not. But there is a problem, and it's the same problem we had in here. We need a prototype for this function because I don't want to write the exact same logic every single time. So because the logic is the same, we can just write it as a prototype here. So actually, the get is nay 3. That's too long. Nay 3. So I guess what I'm going to do is just oh, but I have to do it like this. Oh, that's a problem. I guess I would do it like this. So we will send the index of the given, how do you say? Of the given cell. That's a given neighbor, right? And so 0 would correspond to this one. 1, 2, 3, 4, 5, 6, 7. Right? Okay. I can do that with an array. It should be nice and full. I need to do an array for these. Okay, so as right, and this. Comma, comma, even though it's at the end, but no matter. And it has a side left and side right. Okay. So here we have the hash nr array, right? And we also need a get neighbor, right? So in that case, it would be self. And actually, I need to take it like this because it's I'm not trying to call the function. I'm trying to get a pointer to it, so to speak, a reference to it. Self and all. And so the gain here is we can just reference these methods through an index, right? So whenever you're trying to do access to multiple members, you just have to pass an index, and that's that. You don't need to specify the function. Because you can you can say which lookup you want to do with just an integer. It's more flexible, I feel. So okay. And I might need to make these two globals actually. It might be worth it because I might want to repeat. Oh, but this one I just can't. This one I can't. Right. Yeah, that's fine. That's fine. Actually, what I can do, just erase the self and pass it in normally. Right? Yeah. And then I can have it as a global, which nice. Okay. So we're gonna do cache and cache. All right. I guess I'm going to take this back. Say sub get n or get neighbor, and it's going to return cache get n. Right? And so I can say get n at index such and such, and just run that function. And I would have to pass the instance. This might be a weirder way to go about it, but that's fine. That's fine. All right. So, do I usually write code like this? No, not really. But we're dealing with squares, right? We're dealing with squares. So let's be funky about it. And I mean, actually, I could translate this kind of logic into C. So if this is too slow, I could rewrite it into C, which would be nice. And I mean, honestly, I want to write a game, and I want it to run really, really fast. So at some point, a lot of this logic I'm going to have to put into a C module, right? But I can always, rewrite these functions, right? The functions themselves, write them in C, and then just use this as a sentry point, so to speak, right? It's not the most straightforward way to write code, but works for me. All right. So neighbor free is gonna have to be hmm, actually it's not good to have an evaluation there now that I think about it. Well, what am I what am I gonna do, huh? Okay. So if has n at index self, so if self has a neighbor at this index and I can make it branchless actually. No, I know. Do get would be equal to the return of does it have that neighbor. If it has that neighbor, then we want to run this function, right? But if it doesn't, then we want to run just an empty, right? So a no up, okay? So we do this at do get, and we pass in self. How do you like that? All right, so that's branchless and utterly crazy, but it's branchless. So what you gonna do? Okay. All right, I like that. I like that. So, so is the cell free boils down to shift nay free and side left it would be 3. Okay. So actually, forget about this. Just gonna do it like this. And if I have to do this bit masking for something else, I'll do it. But right now it's not really that interesting. And all right. Oh, that's all. That I have key bindings that I never set and make me go to the top of the page, to the top of the file or the bottom of the file, and I don't know what that key combination is, but every single time, man. This is crazy. Okay, so it's shift, and this apparently I hate it. I absolutely hate it. Uh, because it's a key binding I don't want, and I do not know how to unset it. I think it's a combination um, of key bindings on the terminal and on the editor itself. So yeah, whatever. Right, so this is actually kind of crazy, but it should work. This is actually kind of crazy, but it should work. All right. Hmm. Now what I'm thinking is maybe, just maybe, I should make it so the does the cell have a neighbor in a given direction? Make that just a constant because we have a static grid. But because we might not always have a static grid, then it wouldn't make so much sense to do that. So kind of crazy. Well, I'll think about it later. I'll think about it later. Okay. Or I could just do it right now. Mm. But I mean, because it's just checking that the cell is defined. I mean, it's a minimal fetch. It's a micro optimization at best, right? And actually, I need to return here. So this is object-oriented programming. No, just kidding, just kidding. But yeah, sometimes when you write this kind of hyper methodical kind of code, it boils down to this kind of nonsense where where you're just writing like 1,000 one-liners that do nothing. Well, what you gonna do, huh? Okay. Yeah. Okay, that's fine. What I'm gonna do is just check that this actually works. And so actually, these modules would have to be on. Oh no, right? They wouldn't have to be on live, right? But they would have to be on the game folder. So, okay, I'll think about it later. Because it might not always be on our path, right? So yeah, I should actually make it the wherever game is, but doesn't matter. Just use cell, and what I want to do is just two things. I want to do cell, make grid, and pass in these. Okay, so I shouldn't do it like this, right? So declaring a variable on global scope, if it's not a hash, because this could lead to some nasty errors. But you know what? Doesn't matter. So I'm just going to pass in here TTY size. Then we're going to draw, and I'm gonna make it so drawing does nothing for now. And then we're gonna check that the not not gird, grid, grid. So grid, if we pass in coordinates, it should give us the cell at that position, right? Yeah. What I'm gonna do is just say grid is 0, 0, and we're going to do some tests on here. Okay. My cell, good cell, yada yada, and let's say cell has and all, and the response should be not. Okay. To print this out. Haha. Okay, so that didn't work. Cell 5. What are you talking about? Oh. Okay. This is not a what? This is a subroutine. Oh, I messed up. Okay. Okay. Right, so that's just a dumb mistake I made. So let's pretend this doesn't exist. That's interesting. It should be right here. Determine this array. I'm indexing into it. I'm referencing it, indexing into it, getting the function itself, and then calling it. 107. That's in here. I called it with the index. Wait up. Okay, so this is kind of funky and weird, but okay. Wait a second. Right, so why is it doing that? That's what I'm wondering. Dude, what's your deal? What's wrong with this? Oops. I thought I had closed everything and that was scaring. Okay. Alright, so I cannot import it? What? What? It was working a minute ago. What's wrong? What's so wrong about this, man? Come on. This was working just fine a minute ago. Can you believe that? Okay, so it's fine. It's just bitching about things that don't matter. Okay, so let me just put this in here so I know that it actually run correctly. Okay, all right. Okay. Okay, so making the grid does not give an error. Okay. All right, so it's entirely in here. All right, that's fine. Let me just check in here. Yeah. Okay. All right, so that's weird. Um, because if you print out a cell, it gives you an instance. And if you try to invoke a method of cell, so this shift here should correspond to an instance of cell. And so it should be perfectly able to call a method of cell. So what's going on here? Really weird how you would do that. And it's defined now. That's not right. There should be no up left. What's that? This one should be at one of the corners. It should not have. It shouldn't have that neighbor. It shouldn't be there. Something here is quite wrong, and I'm not entirely sure. Give me a second here. Oh. Okay, so I probably made a dumb mistake. You know, obviously I made a dumb mistake somewhere. But what could it be? I mean, this is messing with my mind right now. But actually, let's do this. Let's try to fetch two different neighbors and see if they are the same, okay? 0, 1. Aha, they are not the same, so it is fetching two different instances of cell. So that's a little bit problematic. Because this one should be like right at the top, and so to the left it should have none, right? So middle, no, side left and up left it should have oh, there it has none. Oh no, wait. Okay, no, these should be equal because these two should be undefined. but they are not. I know. Okay, so because it's doing negative indexing, right? So that's why it is doing negative indexing. So that's not quite right. So where it should be giving me the last element is giving me the first. So that's kind of crazy, but actually it's kind of cool. That's kind of crazy, but actually it's kind of cool because it loops back. I think I actually kind of like that because can I move upwards, right? And suppose you're like right at the edge of the world, right? So you're right here, right? And you want to move upwards. And let me just draw these cells here. And you want to move upwards. There's nothing in there, so you would just vanish and start at right there. Makes sense to me. Makes perfect sense. And I wouldn't have to handle this corner case. I kind of like that. I kind of like that. Because you just scroll. You just scroll. That's fine. It's perfectly fine. And I mean, this one, we're working with world coordinates, and so that's what I would like to happen. You go to the edge of the world, there's no edge of the world, you just go back. The world is round, right? It's not flat, it's round. The representation is flat, obviously, but in reality, the world is round, and so you should be able to loop back, is what I'm saying. And that's an interesting mechanic. So actually, I'm gonna leave that in there. It's not a bug, it's a feature. And what I'm going to do is we're going to disallow negative indexing on a, how do you say, on a I can't quite think about this. We're going to disallow it on local coordinates, right? Or will we? Well, I'll see it when I get to working with local coordinates. Okay, so that's okay, and so this one is kind of redundant. That's a problem. Because if there's always a cell on the other side, then why perform this check at all? So, okay, so that kind of sucks. I wrote all of that for nothing, basically. Okay, that's fine. Let's just get rid of this. Yeah, we just loop back. All right. And we'll need a method. And actually, what I'm gonna do is just have this method to occupy and free a cell. Right. And so to this, you would pass the reference to the entity that's occupying the cell. And to free, you just set it to on depth. Okay. Okay, so now let's fix. Oh no, actually, the bug was with the has a given um, neighbor, and since I decided I'm not gonna do that, then whatever. Okay. So what we need to do though is we need to check that we are not stepping out of the max bounds, because that will not be nice. So what we have to do is when we step out of bounds, we need to loop back. And so what I'm going to do is I'm just going to say that y is world plus this bounds plus coordinate, and we're just going to bounce check, I guess. Okay, so if y is over equal, actually equal size y, then y would be 0. Actually, this is y and x. Okay. All right, nice. Nice. Okay, good. So what I would like to do now is to draw this. Okay. So, iterating through all of the cells would be a little bit crazy. So what I should do actually is have like a string ready-made, right? So like a string ready to go with like all the little things, and that actually I should put on scene, but just for now, I'm gonna say map, I guess, make that a string. Hmm. Whatever. It doesn't quite matter. So let's say hash map dot equals. We're gonna put a single hash there. Okay. Then at the end, we're gonna put a new line. Okay. This is it's not going to look good, but you know, just to give ourselves an idea. Actually, let's just make it a hash, and let's print it out. To map, and this is just for testing, right? I'm not gonna actually use this, but you know, just to have something. Dot cell map. Okay, that's not what I intended. Oh, I need to actually call draw. I need to make grid and then draw. Okay, there we go. Okay, that's fine. Now what we need to do is make it so I you know make it so every cell has like a certain character, right? So So right, because that would depend on the entity. So for every entity, we would have a different representation, and that would depend on the draw. So yeah, it's not something we can decide at this point, but this is just to know that it itered through the whole screen. Okay, so just one more test. What I want to do is I'm going to draw. I was going to say my cell is equal to cell grid um, at 0, 0. Okay, so the one at the top, and I'm going to occupy that cell, and I'm just going to pass it a 1 just because. And now we're gonna swap to the cell right next to it, and check if the neighbor is free, and it should return none. Okay, so side left is free. Printf. I'm gonna make it like this. Cell is side left free. And it oh oh, this shit again. Come on. But I mean, if I'm invoking, oh no, no. What? If I'm invoking, huh? Wait a minute, wait a minute. Am I blessing these references? Yes. Then what is going on here? What, do I need to do it like that? Nope. Wait a minute. Let me just print this out because this is uncanny. I'm obviously doing something wrong, right? But no, it's a blessed reference. Then, so what's going on is here this instance, the passing of this instance to the method should be implicit, but it's not. It's not what's happening. That's kind of crazy. I'm gonna put the draw in there just to be spiteful. Okay, so it's giving me a number, but I don't know what. Hmm. Oh, this returns nothing. I'm sorry, I slipped my mind. Slipped my mind. Okay, it's free. And once again, it's doing this shit. Okay. Okay, so I need to do it like this. Okay, so my neighbor return the neighbor, and then neighbor is free. Yeah. It should be implicit. What? What you talking about, Willis? So this one. Give me a sec. It's a little bit stupid what's going on. Okay. Let me think about it. Motherfucker, it is a reference. Then why are you what? What? You know? What's going on? Oh, now it works. You shitting me? What is this? Come on. Oh, okay. Right, so right, because I need to parenthesize it. Okay. Okay, that's not very intuitive, but you know, that's fine. That's fine. That's fine. Okay. And the cell, the neighboring cell was not free, meaning the occupy thing works. Okay. So we can tell if a given neighbor of a cell is occupied, and thus then we would have to in the case that it was occupied and we were trying to move from one cell to another, then we would have to get whatever is occupying this particular cell, and to do that occupier, you write it like that. I'm gonna write it like that, which means occupier. It's just another way to say that. So what we would have to do is if it is not free, if the neighboring cell is not free, then we would need to get the entity that's occupying it, right? So cell neighbor, that one neighbor we're trying to get, and the occupier, and print up and print that out. Okay. Wait, what? shouldn't be giving me a... Oh, right, no, that's correct, actually. Okay, 68. I need to parenthesize this as well. Oh, because I'm not supposed to return that. Okay. Are you shitting me? Okay. Okay, okay. It is a reference. You shitting me. You really are shitting me. Okay, must be that that whatever is on the right is executed first, I guess. Nope. No, it's just being weird about it. Okay, that's fine. There we go. Okay. And now if I say potato, it's gonna give me potato. Okay, so but pop potato, right? So okay, right. So yeah, that's fine. That's fine. So we can get if the neighboring cell is occupied, and we can get what is occupying the neighboring cell. So this we can use for pathfinding when we get to it. So all right, that sort of covers some of the basics. Next up, I guess we'll be looking at actually occupying cells with entities, and that would mean working on the entity class itself. But you know, for now, that's it from me. Okay, so yeah, goodbye.